Boston Dynamics has developed a surgical simulator for training and performance assessment. The surgical simulator uses real-time 3D graphics, physics-based simulation, high-fidelity force feedback, and interactive haptics. Haptics lets you reach into a virtual environment with your hands to touch, feel, grasp, and manipulate simulated objects. BDI's simulator is the first to give you a realistic sense of touch, in addition to the senses of sight and sound. We are focusing on open surgery anastomosis, a common surgical task that is a component of many surgical procedures. The trainee works at a surgical station holding real surgical instruments attached to force feedback devices. The trainee holds forceps in the left hand and a needle holder in the right hand. The forceps are used to grasp and stabilize organs during suturing. The needle holder is held in the right hand. It is used to grasp the needle and drive it through the tissue. Both instruments are standard surgical tools fit with sensors and attached to high-performance force feedback devices. The user can feel the surface of the organ when touched and its deformation when stretched or punctured. Anastomosis can be combined with other elements to train a variety of more complex surgical procedures. At the heart of the surgical simulator is a dynamic organ model. It calculates the behavior of the organs, including their gross motion, overall stretching, local tissue deformation, needle penetration forces, and surface friction. The simulator also detects contact and calculates contact forces among the tools and organs. The surgical simulator supports quantitative assessment of basic surgical skills. This demonstration shows elements of a suturing task that have been instrumented to provide quantitative feedback to the trainee. The green dots show desired target locations for needle penetration, while the curves show needle forces. The task requires precision needle placement, as is required during anastomosis. As the trainee performs the task, the simulator measures time to completion, accuracy of needle placement, tangential tearing force, tissue surface damage, and several other parameters. Once the task is complete, the simulator scores the trainee's performance. This sort of measured task can provide quantitative feedback during training, allow proficiency testing, and may someday be used in certification and credentialing.